I talked about formulae. So these are the formulae which we have got to by heart, alright, before we get into rotational dynamics. Alright, so in first place I have got kinetic energy, half mv square. We are all aware about, right? Now v we know is equal to r omega, so we can fit in half m r square omega square, r omega square, right? So r square omega square. Now in this case we find this identical, v square linear velocity equivalent to angular velocity cancel, so m is equal to mr square. We get translational mass is equal to rotational mr square. Now mass we know is inertia, it cannot move by itself. Alright, according to Newton's second law, inertia is one which cannot move by itself, and if it is moving it cannot be stopped unless an external force is applied. Alright, so mass is inertia, so this we call it as rotational inertia. Alright, so this is rotational inertia. Now suppose it's a ring. Suppose if it's a ring, you have got mass over here, alright, mass of the ring rotating, and suppose this is the radius, then what would be its moment of inertia? Its moment of inertia would be mr square. Its moment of inertia would be mr square. Alright, so that's about moment of inertia. So what we concluded from here is I is equal to, what we concluded over here is I is equal to mr square, where m is mass of the material and r is the radius. Alright, okay. Now coming to centrifugal force, centrifugal force, it's mv square over r. V square again, you can write it as r omega, r square omega square. So 1r and this gets cancelled, so what we are left is mr omega square. So that's the formula for centripetal force. Centrifugal force. Centripetal force, if it is inside, we normally put minus, and if it is outside, that is centrifugal force, it's positive. Okay. Now coming to third is force is equal to mass into acceleration. Now right now we learned that linear mass is rotational inertia. So instead of mass, I can jot down I, and instead of a, it would be alpha, angular acceleration. Alright, and so we can also write it as m r square alpha, mr square, I is mr square, right? Mr square, so instead of this. Now I need to tell you something about torque. Now see, force is just, it's like this, I apply force here like that. Okay, but in case of torque there has to be two equivalent opposite force. Now suppose this is the thing which you have got to rotate. Now so I have got to apply equivalent force from here as well as from here. So both the forces has to be equivalent, they have got to be opposite, and they cannot be collinear. If I apply over here like this, definitely the rod won't move. Alright, so equivalent, opposite and non-collinear, only then the torque functions. Alright, so that's what is torque. Now we talk about momentum. Momentum P, mass into velocity. In case of rotational or angular, it is capital L is equal to I omega. Alright, then moment of force is force into distance. Distance from the fixed point is moment of momentum and moment. Alright, torque on dipole. So torque on dipole is force into perpendicular distance of two forces. Now suppose if something like this, torque have been applied. So torque have been applied. Now if torque is applied, it is one of the force into the distance, alright, force into the distance. Alright, now when we come to work is force into displacement, we know that. So instead of force we can have torque, and instead of S we can have theta. So that is what is work. This is work in linear, this is work in rotational, alright, or angular. Now what is power? I shall put in here itself. What is power? Power is work upon time. Alright, so work is F into S upon T. S upon T is velocity. So this becomes force into velocity. So power can be work over time. That is rate of doing work as power. Work we can split up into F into S. S over T becomes V. So it is F into V. So work is equal to F into V. Now this, if I now write it in terms of rotational, I can jolly well write here tau for F and omega. Alright. So this is what is for power. So you have got to keep in mind. So this let me put it as 8. Now what finally remains is impulse. Impulse is denoted by letter J, and it is F into T, force into time. Now if force is there, then we can also jolly well put in rotational tau into T, that is time. Alright.